Hi guys, so I was asked to do this video about brushless gimbals, specifically the 3-axis brushless gimbals. As you can see in the picture, we've got the handheld one, and we're going to be talking about some of the other ones that you would mount onto a quad. Now we're going to talk about how you would use the software, as well as the overall setup of the gimbal, just on a general basis of it. If you've got any specific questions, then let me know and I can do a follow-up video, or maybe just simply answer the questions as easily as possible in the comments below. So this gimbal uses much larger motors as you in this picture, and we're going to talk about this one as well as the integration of the buttons or the joysticks to move it around through control. And we're also going to briefly discuss the wiring of the actual AlexMos board, as you would have it in both gimbals, which is pretty much the same. Now you can see a little bit of that board in this picture. This would be one of the ones that you'd use with a GoPro camera. And you can see how the 3rd-axis board is basically connected to the original board that has the 2 axes. Now there are different types of boards, so you may have a slightly different one. The newer ones are the 32-bit boards, the older ones are the 8-bit boards. The overall wiring is very, very similar, but we're going to do a quick overview of the general wiring and setup in this video, and we'll take it from there. So a bit of history with the 2-axis board. The most important thing is where the sensor sits and the sensor wiring. If you look at the wiring, as it says on the top left-hand corner, the black cable must match at the first of the right. Now that basically means that there's actually another alignment that you can plug it in, so just make sure that it's plugged in correctly, otherwise it won't work. And from this picture you can basically see all the connections throughout. You can see the 2 ESCs controlling your motors. You can see the power on the left hand side, the positive and the negative. So if you orientate your board, it'll show you the pitch motor and the roll motor. It shows you the power. It shows the plugs for everything, and just generally the way it works. Now if looking at the section where on the right hand side you can see A0 and A1, that's basically the controls for your roll and pitch, and those are labeled as well, and it basically also tells you which should be what. So you've got signal, your VCC and your ground. So when you connect that to your receiver, then you would do it in that manner. You'd have the signal wire, then your VCC, and then your ground wire being your black wire. Okay, so this is basically the first picture of the 3-axis part of it. You can see the extra part is the 3rd-axis board. It's the medium-sized board, and I just wanted to show this picture before we get into the actual wiring of it. But everything is the same as the 2-axis except the addition of the 3rd-axis board. So we're going to look next on the picture of the wiring, and we'll talk a little bit about that as well. Okay, so this is basically looking at the wiring. Now, if your board comes pre-configured configured and it already has everything, then it makes your life easier. But if you buy everything separately, like for the handheld gimbals, then you're going to have to do this yourself most likely. Now, the main thing is getting your 3rd-axis board soldered to your 2-axis board. And this basically shows the wiring on the left hand side. You can see the way it's basically labeled is if you had your pins soldered to the 2-axis board, you would literally just have to place the 3rd axis on top of it in this orientation, and it'll line up perfectly, and you just solder it together. And that's basically the way they usually come pre-configured, and it makes your life easier. You don't have to do that. You can have the board put off separate to the side. If you really want to do running wires, I don't know why you'd want to do that. It's just easier having it on top. So once you have it on top, the only extra that you would have from the 2-axis is the extra motor, and that comes off from the bottom part. There's the 3 pins for that you'd have to solder in. And then finally, if you want to control that the yaw, then on the side, on the left-hand side, you've got the wiring for, or the pins that you can put in there to control the yaw motor. Now, the way you do that is exactly the same way as you do it on the 2-axis board. You just have to make sure that the labels match up between each other, just like with the 2-axis board. Now, like I said, it'll differ from board to board, so just be careful and just check the labeling on the boards. And I basically already explained the different meanings of those. If you're not sure, you can actually check the labels, your VCC, your ground. Ground's always black, and you always have a signal, and your VCC being red, your live, basically, your positive. So as long as you line those up correctly, you'll have no problems. And it's the same thing going to your receiver. You want to have your signal going to signal, your ground going to your ground, and then your red being your positive, which is always usually in the middle. It is always in the middle for most receivers, so that'll go through to in the same way onto the board. Now, just quickly on the right hand side, you can see that the sensor board is also labeled, and again, it depends on the type of sensor you get. If you get it with these like this, where you have to wire it up, then this is the layout, as you can see over here with the wiring. If not, if you get it like in the previous board, then it's a bit easier, and you just need to line it up and plug it in, and it'll work. So the biggest thing is how are you going to control this board. If you're just using it as a brushless gimbal sitting on a multi-rotor, then it's pretty simple. You know, most people just want to have the control over your pitch, so you can look down, you can look slightly up in that, not too much with the yaw, although you can also use the yaw. Now, most people would use a separate transmitter and receiver, or you would use some sort of slider switches on your transmitter that you already have, if you have enough channels. So that's not a huge thing to do. However, if you're using the joystick like you would on a handheld gimbal, then it's slightly different, because these outputs that I've been talking about wouldn't go to your receiver, they would go to the joystick. Now, that you'll have to obviously have a look at the joystick, and you'll have to have a little bit of understanding over there of the joysticks, but they are very, very simple. If you buy them from the same place that you buy those gimbals, then most of them come labeled very well, and they're all going to also have three plugs: your signal, your red wire for positive, and then your ground wire for the negative, or your black wire. And then you just plug that in, and it'll control it. And basically, you would do that in the same positions that I mentioned before. So that should be pretty straightforward. The only thing that will be different is in the programming. It's not going to be the same type of setup, and I'll talk about that in a different window when I get to that. Now, the last thing that I am going to show right at the end is how to, where the wiring would go to change modes, which we'll discuss in the next few pictures for the actual program. Okay, so this is your simple BGC GUI, and I'm not going to go into every single detail in here, but I'm going to talk about a little bit of what you're going to need to do in each window. Now, in this window, we're looking at the basic section. You can see it's highlighted in blue, it's basic, and this looks at the PID controller and the motor configuration and a few other little things. Now, one of the little things that is very important is under sensor on the bottom right. You need to do the calibration of the accelerometer, and you can also do the calibration of the gyro, but what I would suggest is not to click there's a section there that says skip gyro calibration at startup. I would suggest to leave that out because that is affected, your whole system is affected by temperatures and pressures and all of that, and you want to leave that alone so that it recalibrates on startup wherever you are. So that leave that as it is. Now, if you're not sure about any of these things, if you go and highlight any of them at the bottom section, it will actually tell you what each thing, a little description about what it is. So let's talk about just a little bit about each one. Now, your PID controllers, that's basically that is your sensitivity, overall sensitivity of each section being your roll, pitch, and yaw, and that you'll have to calibrate yourselves depending on the size of the motors you have, on the type of gimbal you have, the size of the camera. What I would suggest is go on some of the forums and just check some original settings that some people have for similar setups, and then they'll give you a good starting point. There's a lot of information available. The default settings are definitely not going to work for most unless something that you've bought comes pre-configured, and some do. Then on motor configuration, again, you've got roll, pitch, and yaw. And let me just talk about the power for a second. The power is going to depend on the size of the motor. The larger the motor, meaning the larger your gimbal, because you're not going to need large motors for smaller gimbals. So basically, the larger you go, the more power you're going to need. So you're going to need to consider that. As far as your number of poles, if you're not sure, you can click the auto function. It should detect it, but you should be able to know how many poles the motors you got have from the suppliers. Now, going back to the power, the way it basically works is, if you think about it, your pitch motor has a certain amount of weight that it needs to work on, and then your roll it has more weight because now it's got the weight of the pitch motor as well and the rest of the structure, and then the yaw has basically all of that together. So most of the time, and this isn't always the case, but most of the time, your pitch is going to be your lowest power, then the roll goes up, and then the yaw is going to be the highest, because you got more and more weight that needs to be incorporated and basically taken care of. Now, the one thing with it that you've got to remember is that you don't want to have too high a power where the motors get too hot. So what you do is you'll test it, get some start values, and then you can increase those powers. And what I suggest is start one at a time. Maybe start with yaw, then go to roll, then pitch, and that goes with the PIDs as well. And then just make sure that when you move around, the motors don't get too hot. You should be able to put your hand on it and have no problem holding your hand on it and have it work. And you don't have to, the heat shouldn't be too much. Okay, in this section we're looking at the advanced. You can see it's highlighted. I'm going to go through this one pretty quickly. You shouldn't have to change too much over here. If you look at the motor outputs, that's the one thing you would probably concentrate more on, and you just want to make sure that roll has roll out, pitch has pitch out, and yaw is your extension board. If for some reason you have a board that already has all three in one board, then the yaw would just be a yaw out. But for the cases that we're looking at, that's basically all we're going to consider. Everything else is mostly default or self-explanatory. Okay, so here in RC settings is where you are going to set up where the input is going to come from. So if it is PWM, meaning it'll be through your controller, then it'll be under that section. If it's not, and it's going to be analog, where it'll be through a joystick, then this is where you're going to set it. So if you look under this one, roll has no input because we don't want to change the roll. We only want to play around with pitch and yaw. So under pitch, you can see it says RC pitch analog, and yaw is RC yaw analog, meaning we're going to use the joystick for that. If we didn't use a joystick, then we'd obviously not use the analog and use the PWM. There is another option, but most of the time we don't use it, but we use the defaults for that. But just make sure it's not under analog. and then you can set also different user profiles, and that is under the command assignment. That's on the right hand side, and you can have different profiles doing different things where the yaw would follow, or the yaw does not follow, and then the pitch will follow and the yaw will follow, or nothing follows. So you can play around with that, and I'm going to look at the wiring for that, like I said, right at the end. But that's where you set the different profiles over there. There's also mixing channels that you can do if you really want to get creative between your roll and your pitch, but that's really getting more advanced. I'm going to leave that out for this video. Okay, so under service is exactly where we're going to basically say what each thing is going to do as far as your different modes. So if you look at the menu button, you're going to have clicks assigned to your joystick. So one click would be in this example motor on, and you can scroll down and change this. 2 clicks is motors off, 3 clicks motors toggle on off, 4 clicks inverse your motor, 5 clicks no action, and long press would be reset controller. Now you can also set different profiles, and then the different clicks will go into those different profiles by doing that, and you can just go down in the drop menu and select that. Battery monitoring, that can help you. I don't feel that it is necessary through the programmer. You most likely going to use a external battery voltage monitor just to check your battery voltage is not dropping too low, and I think that's going to be the easiest on there. So under service, you just want to look at the menu buttons and what each click does, and again we're going to look at the wiring right at the end on how to do that. So finally, we're going to look at the follow mode, and this is where you're going to select what is going to be which mode is going to follow. So it's right at the bottom. You can have follow yaw, you can have pitch and roll, and then you can have a combination of those. And the reason for that is because sometimes you just want to have the yaw following, sometimes you want to have the pitch following, sometimes you have the pitch and yaw following, and that you would do under different profiles. So you would save one profile that would basically allow you to let's say follow nothing, and then the next profile you do everything again. Just make sure that you copy and paste your PIDs and everything to be exactly the same, and then you just change and you say follow yaw, and then the next profile you'd have yaw and pitch follow, and then by doing that, by clicking through the buttons, you can change the different profiles, and then you will be able to get different effects. And that's pretty much it. Now there is another section of firmware upgrade right at the end, and I think that's pretty self-explanatory. And then the real-time data is when you are just testing your PIDs, you can go into real-time data and just check to see that you want to get the minimum amount of movement, so you want the line to be as straight as possible, so you can check for any vibrations in the motors. So that's pretty much it on that. The last thing, like I said, we're going to look at is the wiring, just to set up the whole click mechanism. So you can toggle through your profiles. Just a final note on this, you can change obviously the angle for where the actual the tolerance. So if you move only by 20 degrees, then, or up to 20 degrees, it's just going to stabilize, and then outside of that 20 degrees it's going to follow you, and you can change those angles as you wish, and that's sitting inside this follow mode section. Okay guys, so as promised, the last part regarding the switch. Some of the boards already come with a switch already pre-installed. That's usually the 2-axis boards. With 3-axis not so much, and you basically just wire it through there. I'm going to put a link over here to show you. It's a very good website that shows you all the connections with the switch and for the joystick, and hopefully that'll help. If you've got any questions about that, let me know in the bottom. Thanks for watching, guys. This has come to be a slightly longer video than I thought it would be, but I was asked to do as much detail as possible on this for people that haven't had much experience with it or are putting together a mostly handheld brushless gimbals, like you can see in this picture here, and just to help them out with that. Hopefully the wiring diagrams that are on this video will help you, and you should be able to do everything from that. There are obviously a lot more functions that can be added, but I don't want to get too much into detail on all the options. So again, thanks for watching. If you got any questions, put them in the comments below. Let me know. Don't forget to subscribe, and I'll see you guys next time. Ciao.